Alright, so today we're doing Chapter 4, Lesson 1, which is all about repeating decimals. So what we're going to do for this first part is we're going to change our mixed number. We're changing our mixed numbers into an improper fraction. So in order to do that, we have to multiply the base by the denominator and add the numerator. So this is going to be 16 over 3. For 8 2/5, we are going to multiply 8 times 5, add 2, so we get 42 over 5. For the next one of 6 4/9, we're going to multiply the bottom and add the top. So we have 6 times 9 is 54, plus 4 is 58 over 9. And then we have 10 3/8, so 10 times 8 plus 3, so that would be 83 over 8. The next one, 7 times 4 plus 3. 7 times 4 is 28, plus 3 is 31 over 4. Then our last one here is 15 times 6 plus 5, and that would be 95 over 6. Okay, so for the second column, we have to change our improper fractions back into a mixed number. So we're saying how many times can 3 go into 16? That's 5 and 1 over 3 is left over. The next one, we have 5 goes into 23 4 times, and 3 out of 5 are left over. Next one, 11 goes into 98 times, and there's 2 out of 11 left. 7 goes into 66 9 times, and there's 3 out of 7 left over. 2 goes into 101 50 times, and there's 1 out of 2 left over. And the last one, 20, goes into 87 4 times, and there's 7 out of 20 left over. Okay, I know we went through that pretty quickly, but you should be able to do that on your own. Okay, the next one says, any fraction can be expressed as a decimal by dividing the numerator by the denominator. The decimal form of a fraction is called a repeating decimal. Repeating decimals can be represented using bar notation. In bar notation, a bar is drawn only over the digits that repeat. So in this first one here, you can see the digit that's repeating is the 3. So we drew the repeating bar, or the bar notation, only over the 3. In the second one, we're repeating the 1 and the 2, so we are putting the bar over the 1 and the 2. In the last one, we are not repeating the 3, but we are repeating the 8 5, so I put the bar notation over the 8 and the 5. It says if the repeating digit is a 0, the decimal is a terminating decimal. The terminating decimal would be 0.25 with the 0 repeating, but it can be written as 0.25. So an example of a repeating decimal, we can just give another one of 0.2222 ... And then you can rewrite that as 0.2 with your bar notation of your 2. So an example of a terminating decimal would be something that just ends. So 0.6. Another example is 0.123. There's nothing after it, it stops. Okay. Letter A says write 5/10 as a simplified fraction. So if we have 5/10, it's written as 5 over 10. The simplified fraction, we could divide both sides by 5, and we would get 1 over 2. Okay, letter B says write 8/100 as a simplified fraction. So we have 8 over 100, and when we divide, our common factor is 4, so we would get 2 over 25. And then 20 thousandths, be 20 over 1,000. You can divide by 20, and you would get 1 over 50. Okay, go ahead and turn it to the next page. Okay, so for part A, you want to write your fraction as a decimal. Your goal is to make the denominator a 10, a 100, or a 1,000. You can also use your memorized fractions. So I'm just going to do the example problems, and then you can go ahead and go back on Canvas and look through the notes to make sure that you have the correct problems. So for 3/5, we're going to make that into a tenths. So we have 6/10, And to write that as a decimal, all we have to do is 0.6. Okay, so you're going to do 1 through 6 on your own. Part B, we have write each mixed number as a decimal. Your goal is to add the whole number at the end. So 6 and 1/2, we should know that 1/2 means 0.5, but we have an 8 in front of that. So the whole thing would be written as 8.5. Okay, again, you're going to go through and do 7, 8, 9, and 10 on your own. Okay, part C. We have to write each fraction as a decimal. Note that we cannot change these fractions to a denominator of 10, 100, or 1,000. Therefore, we will need to do long division. So 1/3, if you don't know that off the top of your head, you could always divide. So 3 on the outside, 1 on the inside. 3 can't go into 1, but 3 can go into 10 3 times. So we're going to subtract 9. 3 goes into 10 3 times. And as you can see, we are going to keep getting the same number. So we are going to write this as 0.3 with repeating sign over the 3. Again, do 11, 12, and 13 on your own. And the last one, write each decimal as a simplified fraction. So this 3 is in the tenths spot, so all we have to do is 3 tenths. Okay, you can go ahead and do 15, 16, and 17 on your own. Thanks for watching.